Right, I think we need to head straight into it, so let us make it maths, and we're solving equations using identities. So, it was way too easy before, right? So let's spice it up. What do you say? Okay, so we've got sine theta equals 3 cos theta. Now, nothing's kind of helped us with this so far, so I've left a little hint here which says divide through by cos theta. So we've just got one trig ratio, because of course tan theta is just sine theta over cos theta. And that's all very well and good as long as cos theta, well, what can we never divide by? Well, we can never divide by 0, right? So cos theta, if it equals 0, things are not going to be happy, so cos theta can't be 0. Which kind of helps us maybe understand those asymptotes at 90 degrees and 270, because cos of 90 is, of course, there you're thinking, well, cos of 90 is 0, so therefore if you're drawing tan, there will be an asymptote there, and that's 0 at 270, so for tan there would be an asymptote. Okay, so this is all very well and good, and this is kind of just a quick aside, but a useful one, that we can't divide by 0, so we can't just divide our whole equation by 0, but cos 0 or cos theta equals 0 is not going to be a solution of this equation, so therefore that's fine. So out of all of that, maybe like, whatever, it looks like we're just going to divide through by cos theta. So let's do that. Let's divide that side by cos theta and divide this side by cos theta. Whoop-de-doo, these things cancel, so the right-hand side's just left with 3. Left-hand side, well, we've got sine theta over cos theta. Well, that's just tan theta. Now, it looks like a very, very simple equation that we've kind of solved before, where you go reference angle, 2 solutions, and go from there. So, go for it. Solve tan theta equals 3 for theta between 0 and 360. And write down, remember that, write down all of your solutions. Okay, well, I'm going to just run through it. So the idea there about asking that is, now I can just run through it. So I'm going to go, cool, my reference angle is, well, I just go tan minus 1 of 3, and somewhere over here is a calculator. Look at that, there it is. And we go shift tan of 3 gives us 71,565 something or other. I'm going to call that 72 degrees because I'm a little bit on the lazy side. Okay, so that's our reference angle, 72 degrees. We know the tan graph repeats itself every 180 degrees. So therefore, and this was positive, so therefore theta is just 72 degrees plus 180k. And therefore we can look at all our solutions between 0 and 360 and go, oh, well, that's not too bad. Let's just go, well, what did I say? 72 degrees. That would be one of our answers, right? If we added 180 to that, they were like, oh, well, remember, I don't know how to do this, so I scratch my head and go plus 180. And I get 251, comma, what, but 252 in my terrible rounding off. Now, if I add 180, I've clearly gone too far over here. And so we can do the same thing backwards. Minus 180 gets us where we would start with. Minus 180, minus 8, comma, whatever. Minus 8 degrees. Okay, and then if we subtract 180 from there, minus 188, I think, let's just check, minus 180 equals minus 188. And if we subtract 180 from there, clearly we're going to have gone too far. So there are 4 solutions, and that's how I do that one. Okay, onwards, upwards to the next one. We could use our squares identity. Remember, the squares identity was that sine squared theta plus cos squared theta equals 1. So we might need to use this in solving our equations. Let's get rid of that. So for this one, 3 cos squared theta plus 5 sine theta equals 1. If we decided, oh, well, let's just divide through by, cos theta, well, that's going to cancel with one of those. This is going to be tan theta. This is going to be 1 over. Looks like a bit of a mess, right? So let us instead replace this cos squared theta using this idea here. So what is, well, we're going to do that plus 5 sine theta equals 1. So what's going to go inside this bracket to replace cos squared theta? Well, cos squared theta is 1 minus sine squared theta. Remember, we had that idea of sine squared theta plus cos squared theta equals 1. And then from that, we go, oh, well, if we subtracted, say, sine squared theta from each side, we'd have cos squared theta equals 1 minus sine squared theta, something like that. Okay, let's distribute this into the brackets. So we've got 3 minus 3 sine squared theta plus 5 sine theta equals 1. Now, we've got kind of a quadratic style equation going on. So if I gave you a similar looking equation, 3 minus 3x squared plus 5x equals 1, how would you solve this equation above my head? And therefore, obviously, we're going to use that to solve the trig equation up there. So how would you solve this equation up here? Well, it's a quadratic, so our strategy would be something along the lines of rearrange, so we've got equals 0, and then we would do some sort of factorization. That's kind of generally how I do it. You know, maybe you might have talked about completing squares. That might have been a legitimate way to think about it as well, and completed a square. Something along those lines is what we'd have up here. So similar idea over here. Let's manipulate our equation so that we've got equals 0 on the one side. So if we did that, all we need to do is subtract 1 from each side. And at the same time, I'm going to do a bit of rearranging. So I'm going to subtract 1 from that 3 to give me 2. I'm going to put the squared part at the beginning, because that's kind of what we used to. And then we've got plus 5 sine theta, and this is a positive 2. Okay, definitely going to be easier to factorize if we multiplied everything through by negative 1. So multiply by negative 1, and there it is. Right? Sneaky way to do it, eh? So now we're going to factorize. Looks like we've just got a trinomial, so bracket, 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 bracket. And maybe just a quick pause on, how you're feeling on factorizing that trinomial. Okay, that's just to feel the water and the temperature. So yeah, that's useful for me to see how you're feeling at this stage. And so for me, I'm going to go, well, I know that's 3 sine theta and sine theta, because 3 times 1 is 3. And I know it must be 2 and 1. So either 2 and 1, but I know it's 2 and 1 this way because I must have 6 and 1. So I must have minus 6 sine theta plus 1 sine theta to give me the minus 5 sine theta. So if you need it, pause it, multiply that out, and just convince yourself that that's that, which means we have our two solutions. Either that must be 0 or that must be 0. Right, because you're multiplying two things. But you know that, so not going to spend time on that. But to go, okay, so that's that. So sine, let me not skip too many steps here. 3 sine theta plus 1 equals 0. It's our one option, which means sine theta equals negative a third. Or our second option is that this second bracket, sine theta minus 2 equals 0. So sine theta equals 2. Okay, so now you can solve each of those. And the only one I'm going to ask you about is this second orange one. Just talk me through your solutions for that equation. Well, sine theta equals 2. Now wait a second. Sine theta looks something like this. Zoop. But what's the highest point here? Well, it's just 1. So when is sine theta going to be 2? When will it equal, there's 2 up there? Never. So this one's easy. There were no solutions for this part here. So we just had this part to solve. So we go our reference angle, and we get our friend out here, the magic machine, to say shift sine of 1 over 3, remember positive value, equals 19,5 to 1 decimal place, let's go for, and it's negative, so we kind of just quickly think, where can I hide away to? Over here. So this is our cast diagram for this yellow equation, and we've got, well, it's negative, so we must be in here and here, so we must be over there and over there. So we've got our two solutions there and there. That was not a great diagram, but you know, it'll do. So we've got theta equals 180 plus 19.5. So we just go here, plus 180 equals 199,5, right? Plus 360k. I just get into the habit now of doing the general solution and then seeing where our options are. Or theta equals, so let's get back to our reference angle, and here we're going to go 360 minus. So 360 minus what we had there gives us 340,5. So 340,5 degrees plus 360. Okay, so they're kind of our two general solutions. Now it's said between negative 360 and 360. So now we get however many solutions there are. So we've got 199,5. We've got 340,5. Well, clearly if we add 360, we're going to go too far. Like the period of this graph is 360. So for each of these, we can go minus 360, minus 19,5. And I still think some of you must surely have a better, quicker way than the slowpoke way I do this. 1995 minus that, minus 160, comma what, 5. Okay, so there are 4 solutions. Again, I know that they're only 4 because the period of the graph is 360. So therefore, they're the 2 within 0 and 360 and the 2 on the other side. So there are 4 solutions. And for common factors, we need to do those 2 more. Those will come in the next one, I think. I think that's a good idea. So, of course, you need to make it math.